Morning, everyone. So we have about 3 more minutes until I'm officially supposed to be starting. I'm using the same repository as yesterday, and I made a new commit that has a bit of test code. The tests fail, and the first thing we'll start doing is to fix them, but I'll get a bit deeper into that when I'm actually supposed to be starting. So for now, just call the repository. Right, good morning. Are you excited? Yes. Alright, so I got a lot of feedback yesterday. I'm very thankful for all the feedback I've got. So today I'm going to be taking it a bit slower. It's going to be mostly hands-on. I have no slides. I will walk around a bit to help out with the solutions, and then I'll present what I thought would be a solution for every little piece. What I want to be showing you today is the 4 different kinds of testing I find the most important. I've put together a little bit of an example with a few exercises that should prompt the errors that could be caught by these 4 different kinds of testing. So the first one is called regression testing, and the abstract concept is just that if you find a problem, first you write a test that shows you that the problem exists, then you fix the problem, and then if ever the problem reoccurs, this test should catch that. If you just fix the mistake, if the problem reoccurs, then you have no idea of knowing unless you did the exact same steps to reproduce the original problem. The second kind of testing is what I call a round-trip test, which is where you have 2 different representations of the same data. You want to test the conversions from one to the other. You use 2 different kinds of round-trip tests to make sure that this is the case. The third one is called the golden test. A golden test is where you save a piece of data that represents some processing of some data that you've done that should stay the same across different versions. For example, if you have, let's say, a blockchain database, the entire point is that the database doesn't change anymore. So if you read from that database, the binary deserializations should stay working across all future versions. That's when you use a golden test to make sure that you can still read the database. And then the last kind of test I want to talk about is called an aggressive test, which is where you make sure, or you try to test that if someone were to send malicious input to your processing endpoint, then they can do no harm. So those are the 4 kinds: the regression tests, the golden tests, round-trip tests, and aggressive tests. Now, you can name these however you want. You will probably find other names than the ones I've used, but the ideas will be the same. So, the example I've put together involves a little bit of code that represents when a thing should reoccur. here is the code. Let's see if I can make it bigger. Is this readable? Alright, so a recurrence represents when something should reoccur. At the moment, something can reoccur every day or every month and nothing else. And the idea is to serialize this concept to a JSON thing and then be able to deserialize it back into the Haskell value. I've already implemented some serialization. It's long on purpose, which means, and I've added 4 tests. And now the idea is to make the tests pass first. When you've gotten the tests pass, we'll go on to the next part where we change the code just like we would in production to allow for more features, but we still have to be backwards compatible. It still needs to work, and an attacker should never be able to supply a certain piece of JSON data that will make you read invalid values. Does that make sense? So for now, the first step is just to not change the tests. Hopefully, I think I got them right. But to change the JSON instances to make the tests pass. And then the first step right after that will be to add a round-trip test to make sure that the JSON serialization and deserialization round-trip nicely. Does this make sense? Know what to do? All right, go ahead. I'll walk around to help out with any issues.
It's the same repository that was yesterday. The changes.
For anyone else who wasn't here yesterday, the repository that I'm talking about is in the Discord chat in the beginner's track. Got more stars than my real topic. If you've never written a from JSON to JSON instance, I recommend looking at the documentation for the ASIN package. And if you still can't figure it out, I'll give an example right here in a few minutes when everyone's had a chance to try it. help with the. I'll see if I can help with the serialization, and then we can get into the deserialization in a moment. So to serialize a recurrence, we just want to make a string out of it, or well, text, but in JSON it's called a string. For every day, we want to make a JSON string every day. And we need to enable overloaded strings. And now one more test class. I think the other should be simple enough. To get this left-hand side of the screen that you see here to refresh constantly and look at the code you've just written and then run the test again if you change something, the command to do that is stack test file watch. This will just look at your source code, and if anything changes, rerun the tests. It's important to set something like this up while you're developing. Yes. Yeah, problem. Right. So the reason for that is these syntactical things are called literal strings, and they will be interpreted as having type string. But in JSON, you need something of type text.
Yeah.
Now, text is also a string in our minds, so actually we'd like the compiler to interpret this literal string as a text instead. And you do that with this language extension called overloaded strings. And then everything that looks like a string to the compiler will be interpreted as the right string given some constraints. Has anyone got an idea for the deserialization? Am I being too fast again? Yeah, how do you do it?
JSON pattern match on the string.
Yeah.
Or JSON. Probably JSON string.
Okay, let's see what we can do.
Class JSON. Yeah, it's class JSON.
First JSON, then you have a value, and then the what?
And we do a conditional.
Yes.
Every day. Just return it every day.
Oh, so there's a helper function for this. It's called with text, and then you give this type of name. Then you get a text out of it, and it will fail to pattern match on anything that's not text. And then you can do case t of every day. That should be like the part of this with text. Nope, it's in JSON. What did I do wrong? Oh, right. This V has to be gone. So this could be rather complicated if you've never done this. So this JSON.with text is a helper function in the ASM library to let you define these serialization instances. The idea is that you give it a nice string for error messages, and then it will pattern match on everything and give a type error with this nice error message if it's anything but a text. If it's a text, then you can case match on it. And this function is actually curried because both of the left hand and the right hand side take an extra JSON value that I've been able to omit, but you can see that in the type. Anyway, the precise serialization and deserialization is not the point of the talk. This should be about testing. So the next step is to write a round-trip test manually. I know the library exists, but it's important that you know how to do this, because I was originally going to give this talk about binary serialization, but then I noticed it's really hard to debug that live. So I went with strings instead. So it's important that you know how to write a round-trip test. So I advise you to do that in the libspec module. There are some helper functions that I'll write down in a moment that you'll probably want to use. First is called for all valid. That gives you an argument that will be generated to be valid that you can use in a property test. The next is called encode, which turns a Haskell value into a JSON value. And then the third is called decode, which takes, I think it's a byte string, I'm not sure. And it turns it into a maybe whatever you want to parse from JSON. I'll write it down. First you'll need to define validity, then you define gen unchecked, and then you define gen valid. And they can all be automatically generated because we have derived generic, so you don't have to do much. It really gets out of your way. I really enjoy how this is just try something, takes all the compiler error messages, and once it doesn't complain anymore, it probably works. Has anyone managed to write a roundtrip test? Alright, take your time. I saw at least one completed round-trip test. So for the people who haven't been able to figure it out, what's the problem? Is it time, or is there a particular issue? Is there something you're not familiar with that I should explain?
You could go through the for all valid with one. Let me explain it.
All right, so let's write this along, look into what kind of messages we run into and how do you fix them. So the idea is that if we encode a value and then decode it, you should get the original value. So you write something like encode a value. This value will be a recurrence. If you then decode it such that this thing is a maybe recurrence, and that should be just the same recurrence, right? That's the Roundtrip test. Now we want this to hold for all recurrences. So we do for all valid of the recurrence to this property. Now we get a bunch of compile errors. Hopefully. Right, so the first problem is we have no gen valid instance for recurrence. So we can just say instance gen valid recurrence. And then it will complain, oh, you have no gen unchecked for recurrence. Then we add gen unchecked for recurrence. Right, now we have no validity, so we add instance validity recurrence. And validity is not imported, so let's do that. There we go. And now our round-trip tests succeed. Is it clear what happened here? Anything completely weird about that? And then I'll push this to the repository as well, so you can follow along if you missed something. And then we'll go to the next part. next part of this little exercise, the customer decides, I don't want these things that I'm trying to have only recur every day or every month, but maybe also every 5 days or every 6 months. So we'll change the data type to be able to reflect that by adding an int to every one of these constructors that represents how many days or how many months the recurrence should have. Now you run into a whole bunch of issues, compile errors I mean. And the exercise here is to figure out the compile errors, how you should fix them, what the safe way is to fix the compile errors, because you could just delete all the code that has the errors. And then it's important to realize that every -1 day doesn't make sense. So we'll have to write a validity instance as well. And then we can start to think about both the golden test and the aggressive test. Let's see if we can write those. So first, I recommend looking into fixing all the compile errors so that everything still works the way it did. And then we will look at the golden tests and the aggressive tests. Oh, and write the validity instance. So this validity instance should say that the int inside is positive, strictly positive, so it needs to be 1 or more.
So change the JSON format as well, or not?
Well, that's exactly the question, right? Because this JSON is suppose you've saved this JSON somewhere already, you want to still be able to read the previous one. And that's what we'll write the golden test for.
Right.
Because the previous one of every day with nothing in it should represent every 1 day. But that's something to get to later. Actually, no, that's something you'll get to while writing while fixing the compile errors.
Yeah, because the round-trip test you cannot fix because it generates random integers.
Yeah, so the round-trip test will just pass if you fix the compile errors, but it won't catch that.
Oh, you mean change the validity instance so it has a constant integer for...
No. So if you fix the compile errors, then the round-trip test will succeed as long as the round-trip's hold, but that doesn't tell you anything about whether it's able to read the previous versions.
I don't think so.
Yeah, sure. Depends on which way you did the round-trip.
I just use constant.
So this is a good question. I haven't told you this. So when you serialize every 1 day, it shouldn't just be the old version. When you serialize every 1 day, you should have the new format where the int is stored separately, even if it's a 1. It doesn't really matter. We'll have the same exercise. It will be more productive to try it out.
So should it be like an object?
Yeah, so the idea I had was it doesn't really matter how you do it as long as the round trip works. The idea I had is to have an object that contains one key which represents which of the two it is, and then a value which is the number. So let's see if we can fix these compile errors. The first compile error is in the from JSON instance. I'm going to worry about that a bit later and first fix the tests. So the first while error that I find in the test suite is at line number 22, which says that if you decode this specific string, it should be everyday one, but every day, but every day doesn't exist anymore in the same type, because now it takes an argument. So this test should be split up into two tests. One is the one from before, which just tests that exactly what you want to encode is what you can parse. And the other is the golden test that checks that what you encoded before, which is what the string says now, you can still read. Does that make sense?
Yeah.
So you split it up like this, and then you get compile error somewhere else for the month case. You're awfully quiet. Either no one has any issues or I'm going too fast again. See if we can fix the other test as well. Now we get a compile error for the encoding tests. What do we do with the encoding test? Alright, I'll take that as a sign that I'm going too quickly again. Every day, string, one plus equals.
Yeah. Those are really people.
We have the automatically Google kind of basically serialized probability diagram. All right. For the encoding test, we'll just encode a single unit test to what we expect it to be. Like so. Now everything compiles and the tests fail. Right? So these are golden tests. They're rather important if you have some sort of promise that your code will still be able to read the old version of whatever data it wrote. So make sure you write these if you use that kind of code. In general, for golden tests, we write the data to a file instead of putting them as a literal string in the test suite. But there's really not much difference, and we just complicate the example here a bit more. So the next step is to make this code compile again. Actually, I mean, make the test pass again, not compile. Has anyone gotten the tests to pass again? object and string actually. JSON object at the same time. Few hints as well. Few hints about the way you write these serialization functions. For true JSON, there's a helper function to write that. It's called object. And it uses these pairs. And these pairs you can make with dot equals. For the from JSON instance, the hints are using with object. Which does what you think it does. And then you will need the applicative choice operator from the alternative type class. And in the case of JSON parsing, this alternative choice thing operator tries the first parser, and if the first parser fails, then it just tries the other parser. So it should help for hints. In general, when you want to make sure you can read the old text, just using the old code can be a good hint. And then adding another case with the applicative choice operator. Here's comfort of the mic. Maybe hear me again on the recording as well. This value?
Yeah.
It's a JSON value, and usually when I talk about it in my code, I write JSON.value, so to make that clear. It's just a JSON value. It's an abstract Haskell object that represents a JSON value. So it actually has 7 constructors. There's one for string and object and number and null and boolean. Okay, so parse JSON takes a value returns parser of the thing that we're trying to find.
Okay.
So this value will come from
Yeah, that would be just commented on both sides. So it's some kind of
Actually, I'll write that down so to be clear. That should help, even though the formatting is a bit weird.
I think you could also, like, I can see it in the that you have this the column on the object.
Sorry, could you repeat that?
The dot column on the object.
Yes. What do you want
To extract the actual every.
Oh, yes, I should write that down as well. That's good.
This.
So that's a good point. To get the values out of an object, there's another helper function which is called dot colon. So, but let's start with the serialization and not the deserialization. Has anyone got working serialization?
Yes.
1, 2, 3,
I have an
4.
issue, but
What's the issue?
Oh, right, so it could be that I wrote the wrong tests, right? There shouldn't be a space.
Oh, that's a good point. So when the ASIN library serializes JSON, it won't have any extra spaces anywhere, so I wrote the wrong tests.
Alright, so. This would be. I don't think so.
Alright, so let's do the serialization together then. So there are two cases that we need to look at. There's two JSON of everyday and the content. And we encode that as an object, where the first argument is every day, and the value is I. And we do the same for the month, except then the key is called every month. And now everything fails because I made the wrong tests. Good. That's wrong. And that's wrong. Alright, so now the serialization passes. Everyone got that? Okay, next step is the deserialization. And I'll scroll down a bit so you can see the helper functions here. Now, if you feel a bit discouraged by the fact that you need to know about all these helper functions, you'll get used to that very quickly. First of all, because you use them over and over again. You can also just look them up, but learning how to read Haskell documentation is a bit of an acquired taste, and it's something you need to get used to, I'm afraid.
I have a question about the dot equal.
Yes.
Because I was checking the documentation of the serializer. And I was wondering
Why is it called dot equal?
Yeah.
I guess because the equals is the colon in the...
Like in Perl, to add something at the end.
Oh, no.
Concatenation operator.
No, definitely not. Okay, good question though. So the dot equals helper function in the serialization, this one, the reason we use this, because these pairs that we're talking about here are just tuples of a text and so a key and a JSON value. The reason we use dot equals is because usually the right hand side is not a value but some other thing that we want to serialize as JSON, and that's exactly what the dot equals is for. Now, I think it's called dot equals because then it looks like key equals value, but it has nothing to do with curl. Just so I know, who here has heard of applicative choice before? Alternative, the type class. 1, 2, 3, 4, 5.
Everyone should have.
Yeah, so you should have seen them in the beginner's track, but maybe not everyone was here, right? And well, I guess then you would have been in the advanced track, so never mind. Who here has used it before? Yeah, so most of us people. All right, so for those of you who haven't, don't be discouraged. It's gonna look a lot easier to read than it was to write. And then you'll see immediately why it works and how it works. It's just, you have to get over the first hurdle, writing it once, and then it will come naturally. Am I almost out of time?
Yes.
All right, let's get started again. I have a feeling no one actually took a break in the gym. Everyone just continued, which is encouraging. So let me get you going with this deserialization a bit. We can just reuse the code that we had before, which is why I commented it out instead of deleting it. With text, it has this interesting type, or copy paste, so that you can try to parse what I'm doing. Oops. There we go. So with text, takes the string, uses the string to make a parser, and then takes a value to try and make a parser for that, that uses that value and makes an A. So what's actually happening here is short for that. Now it won't compile because this needs to be every day 1. This needs to be every month 1. This compiles and this will pass the golden test but not the others. Alright? This is just using the old code that we already have. So now you'll write an alternative parser in the case that this one is so that it can be used in the case that this one doesn't succeed. So you'll put something here.
You can remove V, right?
No, you can't remove V.
Right, so it's not. Okay, so it's not applying to that side.
So you could remove V before, but now you'll have to apply it here as well.
Right.
So you'll need to keep it now. So you're going to make something right here that takes a value and produces a parser. And the hint is that you will put the with object with the string and something that takes an object and produces a parser in this spot where undefined is right now.
And you need to import control on the thing here.
Yep. There we go. And now we get undefined errors instead of failures, which is exactly what it was. Okay, good. So this undefined should be replaced by a call of with object. Let's see if I can scroll down. With object and then this function right here. Does that sound more doable? This talk wasn't supposed to focus so much on the actual serialization and deserialization, but more on the tests. By the way, someone pointed out that the data model in JSON for the thing that we're trying to represent is actually quite bad. They're right. The reason we did it this way is because now you get to write another golden test for the next step. For the people who are having trouble with writing the spot that needs to, filling the thing that is currently undefined right here, what is the issue that you're dealing with? Is there any particularly nasty compile error? I heard someone say I was too embarrassed to ask for help with this certain issue they had. Really, don't be embarrassed, you can tell me. I've run into all of the same issues. Yes? Yeah.
I'm Kerckhove here. I'm not really sure how to write. So that's it.
Aha! All right.
Yeah,
So,
I think that
right. So what's happening here is that with object, can you see the type of with object? It takes a value at the right? You're not supplying a value at the end here. That's the first problem. That's why you get type errors. And the second problem is that you're trying to put this within the with text.
Yeah.
So you need to put the brackets around that.
Okay. So yeah. So the should have like two alternatives. First,
Yes, and now you need to apply a V there, just before the applicative choice. Look at the...
okay.
Yeah, you need a V right there.
Yeah, that's right.
And now you can write the second case, which we'll use with object, and then you can case match again.
Right. Okay. So.
Or you can write what you did, which is actually a lot cleaner.
Except I don't
right. So if you delete the otherwise case right now, and now you supply a V to the with object call, right in between brackets, for the other one as well. I think that should compile.
Look every day. Can you check this every day?
There we go.
Nice.
Alright, anyone else having some issues with this? Okay. If you're interested in writing another set of golden tests and a bit more parsing code, you could add another something like maybe time of day right here, such that the client can specify that they want to be reminded at a specific time in the day every 5 days, for example, instead of just every 5 days. This would just be more exercising what you've just tried. So we'll go on to the aggressive testing once we've done this instead, but you can still do the exercise afterwards. So for now, let's finish this up. So what we'll do is we still need to be able to parse the everyday and the every month from the objects. So what you can do is JSON with object recurrence, and then supply a function that takes an object, and then you want to parse a with every day and take the value that came out of asking for the everyday key, like so. So now it will parse every day, but it won't parse every month. And I made a mistake with brackets somewhere. now we can parse every day, and now we can just add another case for every month. Right, so. And our test pass. Can everyone see how this piece of parsing code works?
Yeah.
Does that make sense? If it doesn't, there's no shame in that, but tell me so I can explain it. Yes?
You might want to explain the fmap.
Right. The $sign between angle brackets is short for fmap, which is what you saw in the functor lectures. It's the infix operator for fmap instead of the prefix function. So what you're doing here is you construct a parser that takes that queries the everyday from the O object, the everyday key from the O object. That will be a parser for the value, and then you fmap the pure function everyday over that parser, so that this parser now returns an everyday that contains as an argument the thing that you just parsed. Does that make sense? Hello.
So there's really no way to remove the V.
No, I'm afraid you're stuck with that. That's not entirely true. I guess Edward Met would have disagreements with with me about this, but I don't mind.
He's not here. So
Once again, what's the type of this dot colon operator?
Yep.
It's a bit confusing.
Dot colon takes an object and tries to find the key in there. If the key is present, then the parser will succeed with the value that you found at the key. If the key is not there, then the parser will fail. Alright? Okay, so now there are a few more problems. There is some sort of vulnerability in our code, which is exactly the kind of thing I look for in my day job. Namely that if someone were to be able to supply JSON to this code, they could maliciously make us parse, or make this code parse, a value that shouldn't be valid. For example, if they sent us a piece of JSON that has the key every day and the value -1, suddenly we have a Haskell value that doesn't make sense. This could form a vulnerability depending on how you then use this value. Does that make sense? Right. Now, what do? We figured out that there's a problem. What do we do now? And this is where regression tests come in. We figured out that there is a problem. What you don't do is fix it. What you do now is you write a test such that your test suite becomes red before you start fixing anything. Okay, so the next task now, I'll push this code and then, so you can follow along from here. But the next step now is to write a test that fails because the attacker can pass in invalid values. Okay? It doesn't have to be a test that tests for all possible invalid values. Just a single one is good, because that test will start succeeding once the vulnerability disappears. And then we'll talk about how you can write an aggressive test to catch this better. But first let's do the integration test. The regression test. If you have any other questions, please don't hesitate to ask, because usually I can help and there's really no shame in not knowing something here. You okay? What's wrong?
It's easy, like, yeah, fix it again and it stops being Okay. That's why I did it the other way. The idea is to watch the moment. Once I use this, okay, already. Yeah, it should work because like this is a pointer.
I think the only problem here is parentheses.
You have pointers.
So if you put parentheses around the lambda, I think it should work. Then I tried to also put parentheses around the start of the or the end of the lambda. No. Start of the O and the end of the lambda. So just before O and just after the two parentheses. Yeah. And do it for the other one as well. You can always remove parentheses later.
That's really important.
Yeah. Yeah, that's fine. There we go.
Now which one you will remove?
Well, there's a tool. There's a tool that will tell you exactly which ones you can remove.
How it's called?
It's HLint.
Yeah.
It will tell you, like, but don't brackets. You wrote this, one I wrote this.
Yeah.
Really sarcastic.
And then you remove them because it's a style suggestion, and then your coworkers go like, yes, but I don't know the precedence of these operators.
Yeah.
Please put them back.
Or even worse, when you think you've learned where they shouldn't go, and then you don't put them somewhere, and you cause a real bug. You can actually turn off individual HLint suggestions as well.
Yeah. This is parents or just like have them just there, you just do it.
Throw them home.
It's the realistic way. Has anyone managed to write a regression test?
The regression test as well. Ja, volledig en daar steeds in de worden van die maken en dan die tell you that all looks like a parse word is not a parse, and it's a parse scale. Yeah. So this is parse scale. Yeah. No. It's a parse scale. Yeah. It's not the parse scale. Here. I think we can even do like beautiful every day.
So I'll give you a little hint.
Yeah, I think it's good. Oh, first time.
The piece of JSON that will go wrong is this. So here you can fill in your regression test.
Isn't the one that really here in the data type itself should no longer be an int, should be something more?
No, because 0 is also not valid. So whether you use a word or an int, you will need an invariant anyway.
Yeah, what I mean is it's not everyday int, it's everyday week.
Why?
Well, because regardless of the JSON, you would still be able in the program to define at some point an every day -5. With this kind of logic. If we fix it only in the JSON serialization, so it should be part of the data type.
Yeah, how will you make it part of the data type?
I would define the data type that is union, well actually, an unknown of, I don't know, 1 to 6, 1 to 7 actually.
Oh, but I think you may have misunderstood what I meant by the data then. With days, the number inside the with days represents a number of days. It's not the day in the week.
Oh, okay.
So you should be able to say every 46 days. But you shouldn't be able to say every 0 days or every -5 days. So yes, you can definitely leave in vulnerabilities if someone does something wrong in the code, but that's another story. It's not a bad suggestion, by the way, about day of the week. Time has this in the library. Alright, has anyone written a regression test? 1, 2, 3. Alright, let's see if we can write it. This, what we'd like to be able to say here is that if you JSON.decode this, if it's nothing, then you should fail. And if you can decode it, then it should be valid. Oh, and we need to make sure that it's clear that we should decode this to a recurrence. That it should fail.
Isn't it in the inverse?
Exactly.
It should fail.
It should be invalid.
Should have failed to decode.
Right. Right, it should fail to go to decode. Oh, I'm so sorry.
So can you just say like JSON proposal should be nothing?
Yes, that's right.
Doesn't compile, like for me.
You need type annotation.
Only JSON proposal, right? This way.
You annotate the result, right?
Otherwise, the nothing.
Yeah, it doesn't matter which part you annotate. The point is
It
that
doesn't know what kind of nothing it is, right?
Can you return pure nothing?
pure nothing will get you nothing in a functor, so I'm not sure what that would mean.
Else? Question.
Oh, should return. Yes, that's right. That works as well. No, wait, it doesn't. Should return. No, that won't work, I think. So here we have a regression test. This fails because of something we did wrong. Right? So how do we fix this? The first step in fixing this is to write a validity instance that shows you what it means for a recurrence to be valid. And then we can change the parser such that if you parse something that wasn't valid, then fail anyway instead of succeeding. So once you've written the validity instance, you can apply a monadic bind to the parser where you say if this thing is invalid, then fail to parse, which is just with the fail function. Otherwise, just return whatever you parse. So the step one is write the validity instance. And I'll write down the functions that you'll need. They're called annotate or delve, and then declare or check. And I'll write them down here as well. So once you've written the validity instance, don't fix the problem yet, because we'll write an aggressive test as well, and then you can see exactly how and why that works. Yes? Sorry? Oh, yes. Right. So if you just read the first line, you'll have a good chance of reading it. This has no instance of gen valid occurrence. That's because you need, if you look at the last 3 lines of the lib spec there, you need to explain to the compiler that you can generate recurrences.
Okay.
And gen objects says that's the instance that explains how to generate truly arbitrary values. Gen valid is the instance that explains how to generate valid values. Because these 2 type classes have really good semantics, they can be completely automatically generated, and you don't have to write any generators yourself. The function that you want to implement is called validate. There we go. Is that cool? Is there anyone who thinks this implementing validation is really, really hard? Now's the time to tell me. So if you implement this validity instance, your regression test is not supposed to be fixed immediately. Yeah, that's exactly right. I think 0 is also invalid. Because every 0 days doesn't really make much sense. Alright, I saw at least one implementation of a validity instance. Does anyone else have it? 2, 3, 4, 5? Alright. So it turns out that int is trivially valid, but if we ever change the contents here to something else, then we prefer that our validity instance doesn't have to be changed. So instead of assuming that integer is trivially valid, we can say annotate I days, and then declare the number of days is strictly positive, I greater than 0, like so. And you can do the same for months. Alright, so nothing is fixed yet, but now you have a validity instance, and this will allow us to write what I call an aggressive test. The idea here is that when we're going to write a test that checks that if ever parsing succeeds, then the result should be valid. This is what we call an aggressive test, and it makes sure that whenever you parse something, you get something valid. No attacker can ever put in something maliciously wrong so that you will read something invalid. Does that make sense? Now, you'll need some dependencies, which is why it's important that you're using the repository that I made yesterday or 2 days ago by now. And then you'll need some imports. I'm going to write down the imports so that you won't have to look for them much. And then you can get started writing the aggressive test. There we go. So the 2 lines I highlighted, you'll need them. Gen validity async just brings a certain instance into scope that lets you automatically generate valid JSON values. And to be able to import that, you need to put it in the package.yaml file in the dependencies for the JSON suite as well.
Would you have both annotate and del?
Why do I have both?
Yeah, that's true. Yeah, I was reading in the documentation.
Oh, just so you can flip them if you want to use dollars or whatever.
Oh.
There's really no, it's just flipped, so it doesn't matter.
Yeah, that's right.
I prefer to use dollars instead of parentheses in general. So if you use declare, you can use declare some string and then a dollar and then however long of an expression you want. But if you use check, that has to be between parentheses. So you could argue that maybe you only want declare, but I started with check and then I added declare later, so now it's still there. Is anyone not sure what to do? What kind of aggressive test are you write that, or what it's for? All right, good.
Should we first just make this one not play?
No. You'll see exactly what, because otherwise the aggressive test immediately succeeds as well. So I want to show you the output as well, so you can interpret it. Actually, I thought, so I'm seeing Lawrence write an aggressive test that is actually much better than what I intended, but it's going to be a lot more complicated to get that right. So instead of trying to decode a generated byte string to see if the result is valid, try to decode a JSON value instead of a generated byte string. There is a separate async function for that, and I'll see if I can show you that. here are the two helper functions that you'll want to use. So there are two kind of regressive tests you can write here. The first one involves randomly generating a byte string, trying to parse it, and then if the parsing succeeds, then the value should be valid. The other kind of aggressive test that we can write here is starting with a JSON value and trying to parse that. The only difference is that there are a lot of byte strings that don't represent a valid JSON value. And if you were to write that aggressive test, while being more general, we would actually be testing the JSON parsing instead of your parsing. Does that make sense? Oh, and you'll need to use for all valid again.
Yeah, I was a bit. I wasn't very good in the size. Yeah, I moved my guitar. Close to the deck. But it's rodents. I can't be. Because I had to feel us. I had one.
Their houses in years old.
Yeah, I can do it every day.
Yeah.
I go live to Sunday, this is Has anyone tried to write an aggressive test and noticed that they always pass?
Yes.
Alright, so at least one person. If that's what happens, that's alright. We'll look into why that happens in a moment and write custom generators. Yep.
So I was thinking of just
Yeah, this is much more specific than what I'm intending. So what we're trying to do is, for any random JSON value that's being generated, if it parses, then it should be a valid result. Not just something specific. And if you did this right, then you should have a false positive in your test. Yeah, these are cases. It is from JSON. The regular line. Yeah, and then it should be valid bar. Should be valid as a single. Alright. Alright. And then the other case, if it fails, then that's fine. So pure unit. Yep. And you'll notice that this passes. And then the question is, why does it pass? So you may have to do JSON look as well too. Cool. So do you have data async? I have this. So it doesn't. Oh, you may have an older version of async. I'm not sure. You may have to import data async parser. Also, it's JSON.
You can do that?
Yep. Let me just check where this result is. Now, result is exported from data async, it seems. Which version of async are you running? Actually, we're running out of time, so I'm going to show you this, and I'm probably going to run into the same problem and see how I fix it. So, the idea here is that if from JSON succeeds for some JSON valid value, then we get a result which is success and contains a recurrence. Then this recurrence should be a valid recurrence. If we get a failure, then we don't care. Failure is intentional. And now, how do we get this JSON value? We say for all valid and pull a JSON value out of that. That's the case here. Right, so my regressive test passes. Why does it pass? We haven't fixed anything, so it shouldn't pass, right? Hold on, does the aggressive test make sense for everyone? Is it clear what happens there?
It doesn't make much of sense. Most of the time it's errors because of the random strings.
Right, so the randomly generated JSON are not very likely to contain a key called everyday and a value that is negative. Right? So what you're actually going to need is to write your custom generators to do this. I don't think we have time for that, so let's shelve that discussion and try to fix the regression test instead. The only thing you need to do there is change your JSON parser a little bit. We put parentheses around the entire thing. Then that's a parser object, so we get the result from it in the do expression. And then if is valid this thing, then we can return it. Otherwise we fail with value was not valid. There we go. That's how you fix your regression test. Does that make sense? Now for the generators, we have about 10 more minutes, so I can either show you how you would do this, or we can quit here. What do you think? Show it. Good. So let me remove. Sorry? So let's remove the fix so that we can actually see some nice errors. Right, so we want to generate specific kinds of JSON objects that could be parsed but will probably be wrong, right? So we're going to write my custom generator and turn off shrinking. We turn off shrinking by just using for all instead of for all shrink. And then we are going to write my custom generator, which is a generator of type JSON value. And this should compile it. Alright, so that compiles. Now, what we want to do is we want to make sure that there is some sort of object that could contain a key, which is every day or every month, and then the rest should all be generated. So, let's say we get a JSON value by generating a valid one, and then just make an object which starts with every day and then puts the JSON value as the key in there. Now we don't just want only every day, but we actually want both of them. So the way you do that is by using the elements function that I talked about yesterday and giving two options, and then one of the two will be chosen at random. Like so.
But still, like, can be below 0, right?
Yeah, so we're intentionally generating valid JSON values that are invalid when you deserialize them. What did I do wrong? Oh, it's not clear what the JV is. There we go. Now we should be generating valid JSON objects that are invalid when you deserialize them, and then we have a good regressive test. And then we in fact do see that this test fails. And it fails because validate, the validation function, reported this value to be invalid. This value, everyday minus 8, is indeed invalid, and it is explained why it is invalid. There is a violated invariant that says the number of days is strictly positive. So this invariant was violated, and you get to this wrong result with this generated value, which is an object that has one key, is everyday, and one value, which is a number minus 8. Is that readable? All right. If you couldn't have written this generator right now, that's completely fine. Writing generators is an art. I like doing it. Not everyone does. That's fine. But it should make sense what I wrote. You should be able to read this. Is that right? All right. That's all I have for you. This was the last hour of testing. I hope you enjoyed it. And I thank you for your attention and for your collaboration is the wrong word. Your participation, that's the word I was looking for. So have a nice day with the rest of the talks. Thank you.